Welcome to the part 2 of the video of origin of tissues, and now we have here the fluid filled space, and this fluid filled space is called blastocele. Moving to the next one, I'm gonna do this. I hope it's not too oval, more circle. Okay, so we have this structure here. Around 1 week after the fertilization, you will notice that a small cavity will appear within the embryoblast, and this will become the amniotic cavity, which is where the baby will eventually float in the womb. And the base of this cavity is lined with columnar cells. Okay, so let me just finish this part. Oh, and these cells are the beginning of the embryonic ectoderm. I almost forgot to mention this. The cells opposite then will transform into amniotic epithelium. So let me just write here that this is the embryoblast. We have different structures here, to be honest. We have the embryoblast, this one. We have the amniotic cavity, this one. Amniotic cavity. We have the blastocele. Blastocele here. We have the embryonic ectoderm here. Embryonic ectoderm here. And then we have the amniotic epithelium. Amniotic epithelium here. Okay, I recommend you to have a look at these structures. Okay, the next one. I'll try to stretch a little more here. Again, it's because I'm just trying to be fast with this illustration. I'm not putting too much attention to the minimal details. Minimal details. Okay, so Here we have the ectodermal cells. What else? We have the endoderm here. And then we have the yolk sac here. Yolk sac here. Okay? So underneath the ectoderm, you will notice that another layer will begin, and this one will form the ectoderm. But you can see that, well, you cannot see properly because it's not well drawn, but these cuboidal cells separate from the ectoderm and line up, meeting in the middle to create a two-layer disc. And this marks the formation of the yolk sac and the early embryonic structure. Which is here. Let me just do this one. Oh, if you think that way is better, I can make the illustration first, and then just explain the structures. For me, it's fine. Just let me know what you think. Okay, so what you notice here is that 7 days later, the ectodermal cells will migrate along the primitive strake and between the layers of ectoderm and the endoderm, and they will form a middle germ layer called the mesoderm. And what you notice is that now the embryonic disc is trilaminar. Okay, what else? Now we have a more complex illustration, which I'm going to do different, okay? So imagine that you are seeing from the, I'm going to cut the structure and you're going to see the part that is cut, okay? Pretty much like this. Okay, so here, if you look at the cross section of this tiny disc, you can see the 3 layers. Okay, the first one, the second one, and then the third one. Okay, you have the 3 layers here, and we have the ectoderm, the inner endoderm, and the middle mesoderm. Okay, the middle mesoderm will be sandwiched between them, and each one of these 3 germ layers will give rise to 3 different, not 3, but will gives rise to different tissues in the body. The ectoderm mostly forms the nervous system and the skin. So let me just do something. So the different tissues will be nervous system and skin, here is just representing the nervous system. Okay, then we have bones and muscles. Yeah, not like a bone, but... And then we have the muscles. Okay guys, and the mesoderm will build up muscles, bones, and connective tissue, and one more. Some eye muscles that come from the ectoderm, and yeah, this coordinated process basically is the foundation for every organ. Not only every organ, but also every muscle, nerve, and nerve in the body. So yeah, guys, this is what I wanted to share with you. Just do this, and then I finish here the second part of the origin of the tissues. So I hope you enjoy the content, and see you next time.